Right, thank you all for joining us today. This is a first podcast for MIDFIX, so it should be interesting. So yeah, I thought we'd do a bit of an intro on MIDFIX. Nigel, obviously aware of what we do, but it's mainly for the audience. So MIDFIX we're a wholesaler to the M&E industry, building services predominantly. We're stocking around 15,000 product lines, and yeah, it's started to evolve into more off-site manufacturing, and predominantly using a modular system such as SIKLA, which is a great product for us. And yes, so I welcome here today Nigel Thompson. He's the director at SIKLA UK.
Thank you, Jake.
And so SIKLA are a manufacturer of modular steel, pipe clips, and I suppose it has its own evolution story as well, doesn't it, Nigel?
Of course, yep.
So on that note, I guess we'll crack on with it. So I think today's podcast it's mainly just to discuss about the evolution of steel, I suppose. It's happened in all types of products, I suppose, and it's certainly happened within modular steel. So yeah, moving on to the first question, Mr. T.
The first question. So, the first question is the evolution. Well, it's not really a question. It's more of a statement. The evolution of steel within the construction industry, from the beginnings, which I suppose happened pre-war. It was in the 1920s when the first lightweight steel framing systems came to market, which technically have revolutionized the way pipe work and electrical containment systems have been installed. You're going back to the days of angle iron, drills, welded frames, and things like that. Strut-based systems now taken for granted, although SIKLA have our own strut-based channel systems. In 2006, we introduced something that we believe would substitute PFCs, box sections, and I-beams to a degree as well. There's a lot that can be done with welded steelwork. Don't get me wrong. We're not dismissing it in its entirety, but there's a way, I think, now that we need, or contractors need, to look at cost savings. COVID-19 thing has obviously taught us that there needs to be better ways of doing things, quicker ways of doing things, more efficient ways of doing things, and off-site manufacturing is driving this. And it's SIKLA, we're at the forefront of this, the same way that MIDFIX are.
So before any modular systems, everything was welded, wasn't it? Down to
pretty much, yeah.
Even for the smallest supports, I'm guessing.
Yeah, absolutely.
And like I said, that happened with your strut-based systems. So I suppose I think it's inevitable with modular systems that it's going to go from, not everything's going to be replaced with modular. We know that. There's always going to be, especially for primary structures and things. But certainly, your smaller, your pipe supports, especially if you've got 1,000 and they're all the same, for example, or even all different.
I agree with you, Jake.
That up.
I think where you're talking about mechanical services and electrical containment, I think these days there's an off-the-shelf solution is going to play a part in the evolution of steelwork anyway. But BIM plays a massive part in it as well. There's a lot more detailing going on in design work, pre-design, tender stage. There's a lot more requirement these days for does it work? How does it work? Does it deflect? Who's going to be responsible for doing stress calcs and things like that? And these become far more important, and they ultimately become the responsibility of the contractor. Usually there is a cost, or a higher cost, for structural engineers and things like that. There's always going to be a need for structural engineers. But if it can be demonstrated with a proprietary or modular system, then why not consult the specialists? Midland Fixings, or MIDFIX, are a specialist in off-site and modular steelwork, and SIKLA, I believe, are at the forefront of this also.
Yeah, absolutely. Okay, so yeah, as I said, we can see it's all evolving. Like I said, people want things quicker, safer. So that moves on to the second question, Nige. So why is off-site manufacturing becoming the go-to option for most construction projects? Obviously, we've seen a bit of a trend. There's all this. There's the buzz anagram, DFMA, and all this. People are talking about this more and more, and it is important. But why do you think that? Why is it now let's say the go-to
Well, I
within the
think
construction
that
industry?
you've got to look at it from, the DFMA, or Design for Manufacturing Assembly, is something that's been going on for almost as long as I've been doing this, and I'm into my 17th year.
I think it stems from automotive. I think DFMA
You think?
I'm sure before so that DFMA. I think I did a bit of research. I think they applied it to mainly automotive.
Okay.
And it's only in the last, say, 10 to 15 years it's now in construction. But I'm guessing it's good. Automotive is efficient. It's fast.
Yeah, of course.
You know, it's
And this is something that you've got to look at. The rate of knots. You've even got, you take something like your fast food restaurants and things like that. They've been off-site for years. They don't build any of these quick yellow-emmed
like
fast
jigsaw
food.
puzzles.
It is, exactly. They build it all off-site. They bodge it together, and then just do their finishing and snagging on-site. And the same way is going with construction projects. Even when you look at the way that civils is done, if it can be cast off-site and delivered in a modular fashion, the central reservations on the new smart motorways, as an example, the majority of those are built off-site and installed, although I do see machines from time to time pouring concrete. But ultimately, the biggest benefit with off-site manufacture is the cost saving on site, and you're taking away that responsibility and health and safety issue. Off-site manufacturing is the future. We've been doing this quite a long time anyway. I think my first off-site project with modules in particular was probably as far back as 2007, and that was the first, like, a fan coil unit module and stuff like that. And then we look at the modules that we're doing now. We're doing large plant skids, we're doing multi-service modules, mechanical modules, and we're doing full arrays of supports for large pharma and energy from waste projects. There is a reason why we're having the degree of success that we are with the off-site manufacture, and that's because the design process demands that there is a need for design compliance. It's just natural, I think.
it's far easier to do that up front, isn't it, rather than
of course,
retrofit it after on site.
You've got a reduction of health and safety issues. You've got reduced labour and rates.
Yeah.
We've got a reduced number of deliveries. You've got on-time deliveries. We've got sustainability. We've got carbon footprint. And
you
the
can
program
iron out the problems before it gets to site, I suppose.
Exactly.
Yeah.
The biggest problem that I see as well is that when you get booms in the construction industry, there becomes a limited number of skilled workers. Now, obviously, welding in particular is a very highly skilled profession, and if you can do it with a semi-skilled labour, then why not? It reduces cost.
With a welder, for example, whether they could all be coded, but everyone has their own different quality of weld. You get better welders than others, I suppose. But I suppose that is a good thing about the modular system. It doesn't matter who builds it, as long as they follow the drawing and we're going to get the same result, aren't we?
Well, you've got compliance, and even things as far as EN 1090 and CE compliance and things like that. It makes it more viable technically. And I suppose the biggest problem with off-site manufacturing is to make it beneficial for anyone. That you've got to be engaged early enough in the project to get it detailed and planned. And I think, from my perspective, I still see a lot of last-minute decisions. A lot of it wasn't considered by a QS, for example. I see a lot of takeoffs generated with strut-based systems rather than steel-based systems, and then you get into this commercial discussion. Why is a proprietary steel framing system more expensive than a piece of 4141 strut, which is what we've quoted it with as an example? And these are going to be the challenges. What we have to do really is educate. There is a better way of doing it. There is a more efficient way of doing it. Whether or not the contractor knows that is available, that is the job of MIDFIX and SIKLA to put it out there. This is what we do.
Yeah. No, absolutely. I said off-site for us. I said we are very much, if we can engineer it as much as we can before, it's far easier, because like I said, if we just send loose material to site, there's normally an issue, and there's something we have to go back, and they've cut it to the wrong length, and it definitely helps. It's far more control, isn't it?
Yeah, of course.
Yeah. Okay, right. So we kind of was touching on it then, really. So I think in the industry there is a bit of a a bit of a preconception of modular steel. You know, particularly that it's expensive, and you know, let's look at it. You can look at that system. It looks more expensive than a piece of angle iron or an I-beam. You know, it looks like it's engineered. So yes, it is going to be more expensive. But what can we, you know, how can we put it across that, well, you know, it's not just the product, is at the end of the day?
No, it's not. And I think you've got to break it down, Jake. And the simple way of looking at it is that if you are a buyer and you look at let's take a 100mm box section, for example. So the first thing that we're going to look at is the linear rate of what a 100mm box section costs. Black steel, out of the mill, delivered to your door. Yeah, it's cheaper. It's far, far cheaper. And then you've got the cost of the welding and the jigging it and the material handling of it. You're bearing in mind proprietary systems like Ziframo are lightweight. You know, they're 50% lighter in some cases. So we've got raw material, we've got the jigging, we've got the welding, then we've got to put holes in it or connect pipe clips to it, or we've got to weld strut to it. These are the types of things that we need to do to make the frame work at least. Next thing you've got to do, you've got to finish it. You know, where's it being installed? Is it in a riser? Is it in a plant room? Is it outdoors? If it's outdoors, there's a high likelihood that it needs to be hot dip galvanized. So then you've got the transit from where it's fabricated to the galvanizer and back. Yeah. Then you've got the cost of broaching tools and mag drills and all these things. And when you think about the time and effort that it would cost to calculate this beyond matrix,
if you add all of that
if
up,
you add it all up, then it's either going to be equal to or greater than something that can be done. Now, we know, you and I, that a length of section with holes already in it that can be connected with, you know, nuts, bolts and washers is far more efficient. It can be done very, very quickly. And the biggest benefit that we're all forgetting here is there's no hot works. You know, we're doing this with semi-skilled labor. You know, it doesn't take a great deal of knowledge and science to be able to build these cumbersome, complex frames. The same skill set that someone assembling a strut-based product would need.
Yeah. No, but it is. I think that is definitely that's the only preconception. You know, I don't think there's a doubt that people say it doesn't work, but I think it's more the cost. And what I always say is, I think, you know, yes, if you're building one little frame, okay, I probably wouldn't build it out of modular steel. I'll probably have something fabbed up because it's. But when if you've got a whole project and they're all different size frames, there's no way, I don't think, especially, so basically I think the more modular steel you use in a job, the more cost saving you get. Do you see what I mean? So you'd save more over 1,000 brackets than 10 brackets.
But you're going to see this, and this is why it's important, not only for earlier engagement, but if you look at the big jobs, we're talking big modules, we're talking riser carcasses, we're talking energy projects, pharma projects, and you look at these large projects that have a high volume of steel. Right, there's 20 tons of steel involved in this job for pipe supports. Yeah, great. We know we've got a kilo rate. It can be, proprietary systems can be calculated in the same way. So all right, say it's £4 a kilogram for galvanized steel frames. Yeah, but maybe we're a little bit more expensive, but we have to remember that the proprietary systems are
heavier,
half the weight of traditional steel sections.
So even if we double the cost per kilogram, it doesn't matter.
It doesn't matter because you're half the weight.
So
when you look at it that way, rather than looking at it, this is an end bracket, this is a piece of section, this is a screw, this is an end plate. If you think of it like a strut-based system, which you can compare it to in the philosophy of it, what you need to do is break it down into, actually, this frame looks like this, it weighs this, and it costs this. Because when you compare them in the same format, cost per kilogram, it will never be more expensive, ever. And we've got case studies to demonstrate that. Obviously, from our history together, we know that, and that's something that we've pitched very, very effectively. The other thing as well, you know, with a system like, you know, it's always going to be perceived to be expensive because of the way that it looks.
I was going to say, people will see it as they will compare it to strut because they'll look at it and go, oh, well, you can bolt it together. Let's compare it to strut. No, they should actually, so that's the preconception, but it's replacing welded. It's where a strut system won't work and they'll think, oh, I've got to go to get it fabricated. well, hey, look at.
But it's a lot shinier off the shelf. Yeah, it's fresh out the galvanizer.
Yeah.
You know, it looks
Box fresh.
Box fresh. It looks brand new.
Yeah.
And you know,
Yeah.
brand new does come at a cost. You know, it looks great.
Yeah.
You know?
And it's engineered. It's already pre-engineered.
Of
isn't
course.
It? Yeah.
And again, you know, when you're talking about pre-engineered configurations and frames, you know, to be able to say that, oh, I've got a goalpost frame of these dimensions and it'll do X, Y, Z load, and you haven't got to consult structural engineers and stuff like that. And these are often, you know, it's perceived to be expensive, but you're missing out on certain things. You don't have to consult structural engineers. It's there. It's on paper in black and white.
Yeah. I'm sure you could probably buy the components of a Bentley car individually cheaper, but you ain't going to build it, are you? It's the same kind of concept. You know, you're basically.
There is that. But I don't have the time to build a Bentley.
One day, mate. That's the next steps.
Small steps.
Okay. Moving on then. So, key advantages of modular steelwork. So we've touched on the benefits of offsite, and I suppose it kind of there's a bit of it blends in this area, I suppose. But what are the main advantages of modular steel themselves?
Well, there's no single answer, Jake, and it's you know, there's quite a long list. Starting with the fact that it's off the shelf. You know, we need to build a frame. I need that frame built tomorrow.
Yeah.
Getting a welder to jig it, to make it, to weld it, to finish it can't be done.
Yeah. You know what? That's a good point, because quite often when we're speaking with contractors at design stages, they always say, "Oh, I'm worried that the design's slipping and we're not going to get this made." I'm like, no, that's the easy bit, because what they're thinking is with traditional methods. Say design takes say if they've got a 6-week program, if with modular steel we could take 5 weeks with design, and still meet the 6-week.
Yeah, of course. Because
whereas traditionally, if that design goes out, that's when they start to worry, and I think that's when.
It's
quite often
perception.
say, don't worry about it. We can build that in a day. I mean, the frame we're doing right now, I think we've literally built that. Was it 20-meter riser in about a day? You know, it's that quick.
And I think that this is something that can't be taken for granted. You know, the fact that we've got something here that's off the shelf. You know, you can come to MIDFIX, you can come to SIKLA, and you can have what you need to build a frame very, very quickly. You know, from instigation of have you got it? Of course we've got it. We've got about 180 tons sitting there in a warehouse ready to be called off, and a very, very high number of the end supports that connect it all together. You know, it's a compact range. You only need feet, angles and section, and most importantly the screw. The other thing you've got to bear in mind as well is there's absolutely no hot works really needed. There are options for hot works, don't get me wrong. We can integrate it into plant room skids, so if you've got a welded base and you want to build everything above that base as a proprietary system, then that works. Same with risers. You know, the riser modules these days, they're large structures. You know, you're talking 15 meters in height in some of these mega risers. Well, you don't build the whole thing out of the proprietary system. You build it out of a system or a steel profile that works, and you integrate the smaller parts within it. And again, the assembly can be done with semi-skilled labour. We've got a reduction in weight up to 50%. One of the things that we do seem to see now, if you go to visit a customer in the city, as an example, they might ask you how far you've come and how did you get here. You know, carbon is becoming really important. So obviously, because of the weight and the fact that it's in stock in the UK, we're reducing carbon. We're reducing the time that's needed. And
I suppose in a lot of cases, rather than, if it's not going to be entirely built off-site with modular, rather than shipping fresh air around the country, you could half build it, flat pack it, so you can stack it on top, and you could get it all in one delivery, for example, and then just finish off the rest of it on site. But
we see this, and MIDFIX in particular have had a great success with AHUs and chiller support frames. We're flat packing them to measure. It's really, really simple. We can connect. We haven't touched on the fact that you can connect to almost any surface. We've got concrete, we've got steel, we've got non-penetrative roof supports, and everything's finished outdoors anyway. It's already hot dip galvanized to C4. It's corrosion resistant.
What if there was a potentially client that they didn't, for example, they didn't want bolted and they wanted to, it's got to be to the primary structure. They only want welded. I mean, is that what could we do there?
Well, we've got loads of means of integrating modular. Like I said, you can use the proprietary systems as SIKLA get involved with welding adapters, welding connectors.
Yeah.
MIDFIX are able to develop and have developed their own custom connections to the sections.
Yeah.
You know, we've seen this with QMEX, and that's something that we haven't really touched on.
Yeah. I suppose that is a good thing about it. You can add interfaces, you can add adapters to the system, because like I said, with the Framo system, it's just the elongated hole, isn't it? If you get that right, you can, if you like,
Exactly.
you can create interfaces. And I suppose the other thing as well about a modular system, all the components are individually tested. It's got component data. You know what you're working with.
Yeah,
you know,
exactly.
If you could get in bits of steel, but where's that steel from? Do you see what I mean? You've got that peace of mind with a modular system that it's and CE marked as well.
Yeah, everything's 1090. In terms of the standard, we're factory production control to execution class 2 as well. So in theory, you're making a support from a proprietary system that meets all the accreditations and compliance of CE. Our supply chain works perfectly in that way.
That's good. Okay, so another question we have, and I suppose it's another preconception really, is what generally in the industry, especially for the large applications and especially your bigger pipe work, high pressure pipe work, steam work, the reason welded systems are always needed is because they know they've got a solid connection. With hot pipe work, you've got a lot of forces. You can't necessarily just have a 3-bolt nut and washer. In most cases, that won't work. So obviously, we know with the Framo system, we've got the self-forming screw. But why is that so? Why is that so important? The connection itself, because we know there are other modular systems, but I suppose it is the connection. Would you say is one of the most important parts?
The beauty of SIKLA's proprietary steel system, Framo, is the screw. It is that simple. The system is great, but the reason it works so well is the screw. And there are many benefits with the screw. Number one, let's have a little bit of history about the screw and where it comes from. Now, if you look at the technology that holds gearboxes and engines in cars, it's this technology. It's a self-forming bolt. If you look at our section as it stands, there are perforations, but there's no threads. So it forms its own thread. It's totally airtight. It's totally shake-proof.
I suppose the proof is, no one's gearboxes.
Well, you don't drive down there's no one's driving anymore at the motorway. So, but there's going to be less likelihood that you will crash into someone's gearbox that's dropped out the fact because the screws came out. It'll never happen.
Yeah.
And it's one of these questions. Why is the screw so good? It's a really, really high quality, high tensile screw that has come from something like automotive. It's finish. If you look at the bolts in your engines in the car, they have that matte kind of grey looking thing. It's that you don't galvanise a bolt like that to stop the threads clogging up and stuff like that. Self-forming technologies. When you look at the connections, we're talking about simple, very quick connections. You can connect a normal end support on our system 4 bolts in less than 30 seconds with the right tool. The other thing as well we've got to look at is when you apply these things, we have torque settings and things like that. We can do that automatically now with the right power tool. Now, nobody wants to be doing systems like this up with a normal calibrated torque wrench. You've got first-hand experience with this. Use the right tool, you do it quickly. And that first demonstration, I remember the first time that I was shown a tech screw going into a piece of sheet steel on a power tool demonstration thing. It's great, but it's the same technology. But we're talking about something going into 3mm steel rather than 10mm steel.
I suppose as well with the Framo system, it's the internal plug, isn't it? When we make a connection, I'm guessing that the internal plug, the reason it goes inside the steel as opposed to outside, if you imagine clamping around the outside, I'm guessing that gives it a lot more rigidity.
It gives it a great rigidity, but one of the things that you're missing with that is that if you have a connection on the outside of the steel, you're not able to use the full exterior surface of the section. The beauty
because you'd have to have one side open.
Exactly. The beauty of the Framo system is that you can use every side of the face all the way up flush to the end of the support. So for example, if you want to maximize space for, say, a series of pipe shoes as an example, which let's take on an energy or farmer job is going to be the likelihood, we can use the full surface area to connect the supports. And we've got the full adjustability on it as well, you know.
Yeah, okay. So is there a way, you know, in regards to the connections, can we prove it? Can we prove that, you know, if a contractor comes to us and we do a design, you know, let's say it's a module. Okay, so structurally we've checked the dead load. That's fairly simple. We know that, you know, the expansion forces are fine, but if that's being lifted up by a crane, you know, how do we prove that the connections work there?
Of course you can. You engineer a structure made from proprietary system in the same way that you would do with structural steel. It's the same principles. It's just put together in a slightly different way. You would look at, for example, so let's take a riser module. You've got to look at the lift. How do you get it from the bed of the truck vertically into the shaft? You know, you look at horizontal gantry modules or pipe racks on farmer and energy projects and things like that. These things are often 6 meters long, have heavy pipe work in them. You know, they're lifted. We've even developed lifting points that can be very, very easily connected to the frame exterior on a module. These are tried and tested pieces of equipment, and they've become a standard product that we have off the shelf. So we're talking about a riser module. You build it off-site, you populate it with your pipe work or electrical containment, lifting points go on, it gets lifted up to where it needs to go. But the benefit with a proprietary system, you can recycle these lifting points. You know, you don't have to use a different lifting point every time. If you've got a set of 4 or a set of 6, and we've seen this with large plant skids. I think the largest we've done plant skid wise, talking 12 tons without the weight of the frame. You know, it's a lot.
Yeah, no, absolutely.